All right, welcome back, everyone. In part two of our lecture today, we're going to talk about conditional statements. We'll dive into multiple conditions and something called ternary statements. And we'll then go into the range method to try to understand what the range method does. And that's going to give us a quick introduction into iterations, where we're going to talk how to iterate through iterable data structures, such as arrays and list by index and value, both index and value. And we'll talk about how to iterate through an object or a dictionary by key or by key and value. Finally, we'll talk about while loops and iterations, and then we'll dive into functions. Where in functions, we'll talk about how a regular function works, a parameter versus an argument. We'll talk about shorthand functions, which are called arrow functions in JavaScript and lambda functions in Python. And then we'll talk about some built-in methods, such as sort, filter, map, and we'll dive into list comprehension for Python. Does anyone have any questions over what we'll be covering during part two? Easy peasy. Then let's start on the fun stuff. We're going to start off with this conditional statements. So here's what we have for conditional statements, right? We're going to go ahead and write a script where our script is going to essentially give us the grade that a student achieves on or based on score. All right, that is what we're going to do here. You can see Copilot just tried giving me the answer to what I'm trying to write out. So let me go ahead and put that to sleep real quick. Let's see here. We don't want main.js, we want JavaScript. Boom. All right. This is the algorithm that we'll be writing. So first, I'm going to go ahead and actually write an object and or a dictionary with key value pairs where I'm going to define the type of grades that are available. So I'll say grades. Hey, if you got a letter grade of A, you must achieve a 90 or above. If you got a letter grade of B, you must achieve an 80 or above. A letter grade of C, you must achieve a 70 or above. And finally, we have D, which is a 60 or above, but let's keep it a little bit more on the professional side. Anything below will be an F. All right, so we know that anything that is above a 0 will be an F. All right. So there's our minimum thing. We're going to go ahead and bring over this key value pairs for JavaScript as well. And we're going to go ahead and throw in that let keyword. So there it is. I have a script that's currently holding an object and or dictionary key value pairs for the minimum score necessary to be able to achieve a letter grade. But now I want to be able to output this information. This is where something like conditional statements come into play. I want to run some logic that will analyze where the grade is currently falling at. And I could utilize something like if-else statements to do this. All right. So let's dive into it. All right, I am simply choosing my path. And for now, let's just do something like passing or not passing. All right, I'm going to write an if statement. I'm going to take in a variable of score, which for now I'm going to go ahead and set to 80. And I'm going to set an if statement. I'm going to check, hey, if my score is greater than or equal to 80%, then I'm simply going to print pass. Else, I'm going to print failed. All right. And I'm going to bring that same exact logic over to JavaScript. But I'm seeing a couple of errors. Let's see what's going on here. All right, we obviously have to turn this into a console.log statement, but I'm still seeing some errors here. Maybe it's because of the let keyword. Well, no, I still have an issue. What's going on? Why is this failing? Let's hear, Keith.
Looks like you don't have parentheses around the score. greater than or
Okay,
equal to 80.
nice. So my condition that I'm checking for should have parentheses. Awesome. Now notice this indentations. This is the first time we're formally covering indentations. Why are these indentations necessary? And are they necessary? So are indentations necessary in Python? Let's hear it, Keith.
Yes, absolutely.
Okay, nice. So we know that indentations are necessary in Python. And the reason why they're necessary is because they show me a nested logic, meaning for this if statement here, everything that's indented belongs to this condition. The else, all of the logic that's indented belongs to the else condition. All right, good. So I understand in Python I need it. But what about in JavaScript? Do I still need indentation?
No.
Or okay, so I'm hearing Keith saying no. So how do I identify that something belongs to a condition? Someone other than, let me pass this question directly to somebody. All right, I'm gonna pass this question directly to, and I'm gonna go with Edward. Edward, how do I know that something belongs to this condition here?
I believe that you might need a semicolon or the one with the comma instead of the actual colon.
Okay, so that would be a semicolon, right? And a
Right.
semicolon in JavaScript is utilized to annotate the ending of some sort of logic, right? So maybe after this console.log, I could add a semicolon, but it's not necessarily grouping the logic to the if statement. And I know that indentation isn't going to group it, so this isn't the right answer. Go for it, Jason.
Wouldn't it be the squiggly brackets?
Yeah, I need some squigglies, right? Some curly brackets
My bad.
instead
Said it
of a
wrong.
colon. No, no, you're all good. To be able to annotate that this is a function, this is a logic that is wrapped around that statement. So now my if statement of score greater than or equal to 80, the logic of pass belongs to only if this condition is true. And this is what happens if else, right? If we run this now, we should both be getting a pass for both JavaScript and Python. And there's our passes. All right. Notice that I mentioned to you indentation does not matter in JavaScript. In JavaScript, I can make this look as ugly as I want to, and it would still be able to read it. Right? It doesn't follow any sort of indicated syntax. Now, does that mean that I shouldn't care about my syntax and how it looks? Absolutely not. Right? There are conventions. Although white space or indentation does not matter in the essence of being able to read your script, it absolutely matters in the ability to be able to read your script. If I'm trying to read some code that another developer created, I expect it to be formatted. When it comes to formatting, I strongly recommend getting something like Prettier as your formatter. This is a code formatter that will format all of your JavaScript code for you to ensure that it's following some sort of indentation or pattern. There's also Prettier ESLint that's available for you. Either of those will do. And when it comes to Python, I believe this one is called PEP 8. Here you go. PEP 8 is probably the best one for Python. All right. So now we went into syntax. We're covering if. We know this from earlier, right? What is this is going to evaluate to? This specific line here of score greater than or equal to 80. What does that evaluate to? Let me pass that on to, I'm gonna, oh, go for it, Ronnie. You're muted.
No, I was gonna ask a question about the extensions as well. Would you recommend like I know me personally, I use where is it? I use something like it's called it's not it's kind of like Prettier, but it's for errors as well. It's called like Code Speller. Are we gonna go
Oh,
over
got you.
extensions? Yeah, I was gonna
So
ask, are we gonna go over like other extensions as well? Because I know like some of them are a lot more common as well, and it just makes the coding easier.
yeah, we're not going to talk about extensions themselves very much in depth, but we could go down this rabbit hole a little bit, right? So this
Yeah,
code spell checker here, this one's a really good one, and I use it a lot.
yeah, I use it
Because
too.
yeah, I have a tendency of misspelling words, and as you've all noticed, code doesn't necessarily tell you if you misspelled something. So this code speller will actually check to make sure that whatever you're writing is an actual word, and it'll tell you if it won't highlight it as an error, it's actually going to highlight it in blue. Let me show you guys an example. Uh, this is not. Oh, that didn't work. I may be running into some issues. I'll have to
I,
demonstrate it later on,
I
but it's
think I think that
gonna.
one might be error lens, the one that you're looking for specifically, because
Oh,
I use
gotcha.
a code speller and error lens.
So it may came up with a blue underscore to let you know. All right. Did that address what you wanted to talk about real quick, Ronnie, or is there something else you want to throw in there?
Oh no, yeah, I was just because I know like some developers have whole lists of extensions that they use just when using VS Code as well. So I was just throwing it out there, like how it's not just the ones that you had recommended, but there's also like a whole bunch of them like Errorlens, Docker, GitHub Actions, Java, TypeScript, like just a whole bunch of extensions that I personally use.
There is a ton. There is a tremendous amount of extensions. What I strongly recommend to all of you is don't depend on extensions to check all of your code right now because you guys are learning, right? I would wait until you're getting closer to graduation to then start really build compiling all these extensions, and we'll pass out a list of all the extensions that you'll need to run the tech stack successfully once you're closer to graduation. But as of right now, we really need you guys to run into these errors. If extensions are always fixing errors for you and you get a whiteboard type of interview, you may make some mistakes that you didn't even realize the extension was compensating for. So that's the reason why we're not diving into extensions just yet. All right, awesome. So this here is going to evaluate to true. Because this evaluates to true, we get the print for pass. And then I get my else statement. All this is depicting is actually a fork in the road, right? It is saying, hey, we've come to an intersection and there is only two paths to take. But that may not always be the case. And here's a perfect example. When we're working with grades, there's four different other conditions that we have to account for. So how do we do this? This is where the else if statement comes into play. All right, I'm going to change this to 90. If a score is greater than or equal to 90, what should we be printing here? What's the letter that should be returned in this case? And I guess I did these backwards, right? We should have probably the value and then the letter. A little bit of a fixing here. Speaking about code formatting, looks like I need some help there too. All right, there you go. So now we have our grades. I want to be able to return the matching letter that works here. But how do I do that? I'm inside of this if statement. If it is greater than 90, what should I be console.logging or printing out into my terminal? This here, Kenny.
Now that they're switched over, you should get A instead of the 90, but it's still a pass, right?
Okay, nice. So I want to grab it from my object or dictionary, just like Kenny said, and I want to grab it by the key. Okay, so we could do something along these lines, right? I could print something like, hey, I want to grab from grades the score of 90. And we could do the same thing inside of JavaScript. I want to grab from grades the score of 90. We'll go through the runner. And this comes back as failed. Oh, that's because my score isn't 90. That will do the trick. Little boot mistake there. Let's try that one more time. There you go. And now we're getting A for both of them. So the score that they achieved was 90. The letter grade that they got was an A. All right. Notice that if I do 95 or even 100 and I execute this, it still returns A. Why is that happening? Why is it that it's still returning A, even though it's clearly not the key of 90? What's going on here? Let's hear it running.
Because you have it set to is equal to or greater than 90.
Nice, greater than or equal to. Okay, so now we went through two of them. Now, I want to make sure that I'm able to account for the other grades, such as B, C, and F. How do I build that up? Let me pass that on to Albert. How do I make the case for B?
I am so sorry. I was filling in on my own, following along. Can you repeat that question?
Yeah, I want to make the case where a student may be able to achieve the letter grade of B. How can I do that?
In Python or JavaScript?
Either.
To Are we adding the else if statements or condition underneath this as well? Or are we switching off the if statement?
No, we could do that, right? We can write an else if or an elif. In this case, this is else if. And what's the condition that I'm checking for?
It'll be score greater than or equal to 80.
Okay, so I'm checking for score greater than or equal to 80. And why 80?
Because we're trying to see if their score returns a B.
Okay, nice. And then what should I console.log if this is true?
It'll be console.log and then open parentheses grades of I'm trying to the key of 80.
Awesome. All right, we could also do this inside of JavaScript with an inside of Python with an elif statement, where we check the score to make sure it's greater than or equal to 80. We grab our print statement and we pass in 80. Now, when we run this through the runner, we can see that we have A for both of them, and that's because I still ran 100. But if I do something like 89 and 80, both of these should return B. And there we get the outputs of B. All right. Now, does the order of these conditions matter? Okay, Simon, I'm seeing you're telling me yes. Why do they matter?
Uh, it's due to the logical word flow. So if you do the 80 first and that evaluates true, it's going to skip the other the 90 per se. Because if it's greater than, say, it's a score of 90, and you say if it's greater than equal than 80, and you put 80 first, it's going to say, yeah, you passed, you got a B, when in reality they got a 90 or greater, which would have been an A.
All right, yeah, fantastic. So let's go and check that out, right? So that we can understand what's going on here. All right, if we check for 80 first. Whoa. And then we check for 90. And let's say we make the score 99. When we execute this, you may expect for you to see the letter grade of A. But you actually get the letter grade of B. All right, here's my JavaScript output. I'm getting a B. But why? Well, just like we stated when we were talking about JavaScript and Python, it is a runtime language, meaning it goes from top to bottom. If it goes from top to bottom, it's going to check everything from top to bottom as well. So if the score is greater than or equal to 80, well, this is true, then I'm just going to console.log 80, which is what gets us our letter B. And it skips our else if and else statements. Nice. All right. Fantastic. Any questions regarding conditional statements so far? I'm not seeing anything in Dakota questions. Okay, nice. Well, now I want to be able to see if a student passes or fails. So we're going back to our fork in the road, right? Depending if a score is greater than 50, then they pass. If a score is less than 50, then they fail. Well, you may be thinking to yourself, all right, well, this is simple enough, right? I can make an if statement where my if statement checks if the score is greater than or equal to 50. And if so, I can go ahead and say console.log pass. Else, I can console.log fail, if I could spell. Well, here, we do the same thing. If score is greater than or equal to 50, then we print pass. Else, we print fail. And this fork in the road works pretty well, right? There's not necessarily anything wrong with this. We can try this out. We can see that that passes. If I turn this into 30 and I execute it this way, well, this also passes. But this occupies quite a bit of lines of code. And when it comes to measuring a code base is measured by something called LOC, which stands for lines of code. Something as simple as this can be solved with a ternary statement. A ternary statement essentially means that we are at a fork in the road. We're looking at two options. And rather than writing an entire if-else statement, I want to write it in a singular line to determine whether I could go left or I could go right. So let's fix this. Let's compress this. I know that I want to console.log. What I want to console.log depends on, well, first I want to console.log two things, either pass or fail. And when I console.log this depends on whether the score is greater than or equal to 50. All right. We're going to concentrate on JavaScript first. Now, if the score is greater than or equal to 50, this is a condition. So I'm going to make sure that I state that this is a question mark. I am evaluating whether this is true or false. If the score is greater than or equal to 50, I should console.log pass. Else, I should console.log fail. All right, so here is my if statement, which is everything to the left of the question mark. My colon is what runs my fork in the road. This is if true to the left. This is if false to the right. This is called a ternary statement. If I come to my runner, you're going to see that that gives me false or fail. And if I make this into 70, this should give me pass for JavaScript. Send it, Jason.
Why wouldn't you put the if in front of the score? You're saying it, but you're not writing. Is there like a specific syntax reason why, or is it just just like that?
Yeah, that's a great question, right? Why isn't it that I'm not writing the if in front of the score? That is what this question mark is doing for us. This
Oh,
question mark is representing our if statement. All right, so we're checking the if to the condition to the left. This is the true basis, and this is the false basis. Does that answer your question, Jason?
yes, thank you.
Of course. All right. Well, if this could be done in JavaScript, it can absolutely be done in Python. Let's see what it looks like in Python. All right, again, we have our if and else statement. And what we're trying to do is we're trying to print. Well, the condition that I'm checking for is of score greater than or equal to 50. And the two options that I have are pass or fail. Well, in JavaScript, this is written a little bit different. I want pass to be my outcome if score is greater than or equal to 50. Else, I want it to be fail. All right, you can see both of them utilize a ternary statement. The difference between them is where the condition is placed. In JavaScript, it's condition, then true, then false. In Python, it's true, condition, then false. We can turn this into 50. If we run this, both of them should say pass. All right, we can see our JS output and our Python output are both saying pass. And if we change them into something like 30, which is below 50, both of them should say fail. And that is a ternary statement. Does anyone have any questions regarding ternary statements? And I always have trouble saying it. I say ternary, but it's ternary. Ternary statements. Let me see here. Yeah, ternary statements. All right. Can I get a measure of thumbs up showing me that you guys have a good understanding of ternary statements? I'm seeing a lot of people doing the physical thumbs up, which is okay. Edward, do I still have you with me? Did I just wake you up? Gotcha. All right, let's go ahead and keep moving, everyone. So now we got our ternary statement set up. We understand this. Oh, I see you have a hand up. Go ahead, Dom.
Sorry, could you just talk through when to use a ternary versus a if else? Like when
Yeah,
should we think we should use a ternary, not if else?
nice. Yeah, that is a really good question, right? And this one is one of those it depends kind of questions. When it comes to writing a ternary statement, what ends up happening when people learn this technology or not this technology, but this convention and they get really good with it, is they start trying to write really complex code in a singular line, right? If you're doing something like that and you're noticing that it's becoming harder to read your code in a singular line than it would be if it was in an if and else statement, then write the if and else statement, right? It is a matter of being able to read your code, right? This one is pretty clear. I have a very clear condition where I'm checking if score is greater than 50. But if I have multiple conditions that I have to check with, if I'm interacting with an object and I'm accessing an entire object key, like for example, let's say we're working with the poke API and we're checking for the amount of damage or URL that comes back from some sort of move, there's a lot of complexity that works in there. Something that I probably want to divide into a couple of steps. That's when I would use my if and else statement. So it's more of a, if it's simple to read and you can compress it in one line, go ahead and do so. If it starts turning into a, oh man, what am I trying to say again? Break it up into an if and else statement. All right, awesome. I see the thumbs up. Thank you, Don. All right. Great. Now let's go ahead and move forward here for double conditions. I want to check if two conditions are met. Right? There's always the good old example if we want to figure out if someone can drink. Right? And this one, I guess an even better example would be can vote, but it's too late now. So now we have can drink, right? We want to make sure that somebody is, in fact, an adult, has an ID, and 21 years of age. All right, so let's go ahead and create our user. We have our user, which holds an age component. Our age component is of 21. And let's do a has ID, which is equal to true. We're going to go ahead and evaluate this in JavaScript. And so can someone drink? And then we turn this into a let. So there's our two objects, or excuse me, an object in JavaScript and a dictionary in Python. And I just simply want to make sure that this individual can, in fact, drink. Well, I can add an if statement. I can say, hey, if user dot get age is greater than or equal to 21. And then here I can check if the user, oh man, I did not, I'm getting my Python and JavaScript all mixed up. I apologize, everybody. If my user dot get has ID, then I could print can drink. Otherwise, I should print you need an ID or can't drink. And else I could print can't drink. Now this is a whole mess, right? I can go ahead and write this out in JavaScript as well. And in JavaScript it's going to look just a little bit worse. All right, we can go ahead and turn this into .age. We want to make sure we wrap this inside of parentheses with curly brackets. Oh boy, this is taking a little bit more than I expected. Sorry, everyone. All right, there's my whole mess. All right, you can see here there's a considerable amount of nesting. Right? I am checking one if statement. I am then checking a secondary condition to evaluate that both of them are true before I can finally get my success statement. And if I run this, this should work perfectly fine. I should get both of them with can drink, right? If I change any of these to have a secondary condition, they should tell me I can't drink. Nice. But there's a lot of repetitiveness here, right? I have my else condition written out twice, and I should be able to recognize that. And there's also this breaking down, which is generally known as something called a code smell, right? If I'm seeing something that's currently waving back and forth, that lets me know that there's probably an opportunity for me to compress this logic and turn it into one. All right, why do we do that? We do this by doing multiple conditions. I want to make sure that they have both the required age and an ID. Right? We could do this in Python by adding the and user.get has ID. And now we don't no longer need this print if statement there. And in JavaScript, we could do the same thing. We can check and user dot has ID. Both of these should give me can't drink. And if I switch this back to meeting our conditions where they do have their ID and they are of the proper age, then it should give me that they can drink. All right, the and statement is checking for both conditions to be true, where the or statement only checks for one condition to be true. Before I dive into the or statement, does anyone have any questions regarding the and statement? It's here, Jason.
Could you explain the syntax shift one more time that you did? Just quickly.
The syntax shift?
Yeah. Like on line six, when you moved it up, just explain that. When you did it, my brain just blanked hard.
Gotcha.
You just moved it up, correct? Like you just backspaced it and moved it up and added the and, correct?
Yeah, so I had a secondary if statement that was indented in here, right? So we recognized that was some repetitiveness. So we removed that second if statement, and I took that condition that I was checking, and I moved it up and turned it into an and statement, right? And I did the same thing on the right-hand side.
Okay, thank you.
Of course. All right. Well, this is and, which is checking both conditions. Let's check this with or. Well, if we run this right now, this would turn out to be can drink. If I remove the ID or remove the age requirements, this would still turn out to them saying they can drink because at least one of the two conditions was met. If I'm using the or statement, both conditions have to be false in order for it to equate to false rather than true. Right, so you could see they're underage and they don't have their ID, then it turns into false. Any questions between and or? Awesome. If no one has any questions, then let's start talking about some range function. And this is going to be the last thing we talk about before we take a nice break here. So the range function is a Python specific function. All right. And the range function actually returns an iterable object. It returns a list of numbers. This function actually takes in two parameters. Well, it could take up to three parameters. Where the first one, you know what, let's write this out like this. All right, so the range function returns a list of numbers, can take up to three parameters. The only one required is the end parameter. All of the other ones are optional. We can provide a start parameter as an option, and we can provide a step parameter as an option. Well, what does that mean? It's going to be a lot easier if I demonstrate it with print. All right, so we're going to go ahead and see what comes back from the range function. And I'm just going to go ahead and pass in the value of 10. when I run this, you are going to see we have the values of 0, 1, 2, 3, all the way up to 9. Well, what happened to the number 10? Why isn't the number 10 inside of this list? Let's hear it, Kenny.
Is it because our endpoint is exclusive so that, like, let's say our first index was 1 and it went 1 through 10.
Nice. Yeah. So this is exclusive, right? The stopping index is exclusive, meaning not included in output. Okay. Well, let's add a start in here. I'm going to go ahead and add a start, and I'm going to pass this in. Whoa, wait a minute. So I expected 10 to be exclusive, but I see 2 is in there, even though I'm passing in 2. So what does that say about my start parameter? Is that inclusive or exclusive? Let's hear it, Kaylee.
I believe that means it's inclusive because it's including the start point.
Nice. So it's inclusive, meaning it is included in output. Fantastic. And then finally, we can go ahead and demonstrate a stepper. And there we get 2, 4, 6, and 8. All right. Does anyone have any questions regarding the range function? Okay. If no one has any questions regarding, oh, go for Simon.
Sorry, stupid hand thing. Anyway,
No problem.
just so that I clarify, because those numbers are conveniently even with like number 2, 2, 4, 6, 8. It's based off of the index, or is it based off of the value? Or
Yeah, it's a great
the
question.
value.
That's a fantastic question. So this is actually just providing me a list of numbers. It's not looking into any sort of iterable data structure. But that's a really good question, right? Let's go ahead and say we have something like, hey, this is my string, right? And my string holds something like, I don't know, let's just say Francisco, right? And I want to iterate through the indexes of Francisco. Well, I don't want to iterate through the value. I want to iterate through the indexes. So I need to evaluate the length of Francisco. So there, in my stopping function, I would pass in the length of my string. And now I'm going to take off the stepper. If I do this, oh, I probably shouldn't start at 2. I apologize. Let me go ahead and remove that as well. Now, if I do this, this here is actually returning all of the indexes that belong to my string. So the string of Francisco holds the values, or excuse me, holds the indexes of 0 through 8. Does that answer your question, Simon?
I guess kind of. So if you did put a step in there, would it be based off of the index location? So it 0 should be F, A, C, S would be and O, would that be the return if it was a step by 2?
Yeah.
Or does that really matter?
So it doesn't really matter in this case because the range function is independent. So what you're doing is you're adapting the range function to walk through the string, right? So if I wanted every other letter of my string, I could put the stepper of 2. And in this case, I do want to make sure that I add that I want to start from index 0. All right. And that in itself would bring me back 0, which is the letter F, 2, which is the letter A, 4, which is the letter C, 6, which is the letter S, and then finally 8, which is the letter O. Did that help at all? Okay,
Yeah,
awesome.
cool.
Nice. All right, so knowing what we know about the range function now, how is it that I could grab all of the even numbers? So I want all even numbers that are present from the range of 0 through 100. And this is where 100 is included. How can I do that? Let's hear it, Kenny.
Would it be 0, comma, length, parentheses, uh, sorry, I wrote down my notes. My string, and then since we're doing just evens, our step is 2 again.
Okay, so I see that we're doing just even. So we're stepping through 2. We're
But
starting at 0.
I want to end at 101 so 100 can be included
Okay,
because my
nice.
endpoint is exclusive.
So where do I add 101?
Will that go just with my string? Like I'm trying to stop at my 101 so the 100 can be included.
Gotcha. So I'm removing this len and replacing it with 101. Right? Okay, nice. Well, let's see this out. Let's check it out. Let's see what comes back. Well, it looks like this works for the majority, but 0 shouldn't be included in here, right? 0 is not an even number. So how can I fix this range function to actually not include the 0? And let me pass this question off to Angel.
Can you repeat it one more time?
Yeah, so currently I have my range function here. My range
Okay.
function is supposed to return all even numbers between 0 and 100. 0 is not an even number, but it's currently being included inside of my output. So how do I remove that 0 and ensure that I only get 2 all the way to 100?
You change the 0 to 2.
Nice. So in line 12, we're going to change the 0 to 2 because we want to start at 2. And there we get 2 to 100. And now we have all the even numbers. Fantastic. Ronnie, I see you have your hand up.
Oh yeah, I was gonna answer the question, but Angel got it. Appreciate you.
Nice. Okay, fantastic. Now this is going to open us up for iteration next. But before we dive into iteration, I think we should take a break. All right, currently right now it is 2:20. Let's take a 10-minute break and then we'll reconvene to talk about iterations. Thank you so much, everyone, and I'll see you back in 10. All right, everyone, welcome back. We're going to start talking about iterations, right? I want to go ahead and iterate through a certain number of values, right? Let's go ahead and start off by talking about a list and or an array. Let's go ahead and call this my list. I'm just going to set this to the values of 1, 2, 3, 4, 5. And actually, let's make this 10 numbers so that we could actually see the difference whenever we're interacting when we're iterating by index. All right, and this is an array. So I'm going to name this my array. All right, so here's my 2 values, and this is an iterable data structure. Now, there's a couple of different ways that I can actually iterate through these data structures. I can iterate by index, I can iterate by value, or I can iterate by both index and value. But let's take it one step at a time. Right? I want to iterate through this by index. And as we talked about earlier, index just simply means, hey, the very first slot is index 0, second slot's index 2, we have index 3, index 4, and index 5. And same thing on the right-hand side, we have index 1, or excuse me, 0, gotta go, 1, 2, 3, and 4. I totally did not count the 2. Wow. 3 and 4. All right. Well, other than my ability to not be able to count, we can go ahead and see that we have all of our indexes here inside of our array and our list. Well, I want to print those out. I want to see those indexes. Let's go ahead and iterate. All right. I'm going to say for index, and I like to do IDX. This here is actually a convention, and we'll talk about that here shortly. We'll do for IDX in range of the length of my list. We're going to go ahead and print IDX. Let's break that down. What is this actually doing? The range function. We just talked about this. The range function is going to return to me a list. So let's see that first. All right, I want to actually print the list of a range function that takes in the length of my list. That is just returning 0, 1, 2, 3, and 4, which is exactly what I expected to see in here, right? We have the value of 0, 1, 2, 3, and 4. Those are the indexes that are being returned to me by the range function. Awesome. So now I know what I'm iterating through. I am iterating through the elements that are returned to me by the range function. And it just so happens that the range function is returning to me the indexes that would match with the values. So now if I were to actually execute my block of code here and execute this in my runner, I'm going to see a running 0, 1, 2, 3, and 4. But how? How is that happening? Well, we know that this range method is going to return 0, 1, 2, 1, 2, 3, and 4. And when I iterate through this, what I'm saying is I am making a variable named IDX, which is going to represent the object that's within the list. So when I print IDX, I'm printing 0. The next object that IDX will be representing is 1. So I get 1 from that print statement, and so on, right? When I get 2, I print 2. When I get 3, I print 3. And finally, when I get 4, I print 4. So I am simply saying for variable representing the element at every iteration in the range of len, my list, which is returning to me all the indexes available within my list. So this is iteration by index. If I want to see the value, I can always call my list at IDX. Right, we could make this a little bit fancier too. We could always say, hey, here's IDX, and then pass that in. And there we could see at index 0, we have the value of 11. At index 1, I have the value of 12. Index 2, the value of 13, and so on, all the way to 15. So that's iteration by index in Python. Does anyone have any questions over iteration by index in Python? Okay, in that case, let's dive into iteration by index in JavaScript. All right, this is going to use pretty much the same convention. We're going to do a for loop, and we're going to create a variable. Again, in this case, I'm going to name it IDX. And then I'm going to use the keyword of in. Now, JavaScript, I don't need to try to fake the indexes the same way that I'm doing in Python, right? With the range function, I'm trying to grab all of the indexes by essentially running a parental function. In JavaScript, I don't need any of that. I just need to call the name of the iterable data structure and utilize the in keyword. That alone will grab all of the indexes, right? So I could console.log idx. And now when I run this, we're going to see that in JavaScript, I get 0, 1, 2, 3, and 4. And just like I did in Python, if I want to grab the value, I could also call my array at idx. All right, so 100 ways to skin a cat to be able to get a value. We can grab it by index, right? So there we can see we're iterating in JavaScript. I have all of the indexes matching the values. All right, fantastic. At this point, does anyone have any questions regarding iteration by index in either JavaScript or Python? Let's hear, Keith.
Just wanted to clarify. So when you use in is by index in JavaScript, and of is by object, or
By
not
val.
object. That's the wrong thing. But I mean elements of the array. Is that
That's
correct?
right.
Okay.
Yes. All right, Dom.
My question, I had two questions. The first was Keith's. Could you just restate that one more time? I had the same question as Keith. Could you say that one more time, please?
Yeah, I was just asking about the difference between in and of in JavaScript because it makes a big difference. So in is for the index, and then of is for grabbing the actual element that the index responds to.
Got it. And then my second part of the question, sometimes I'll get hung up trying to recreate the range function instead of doing let index in my variable name. When is the right time to use that in JavaScript? Like I was sort of thinking, oh, you're using the range, so we would have used that here. And wanted to clarify.
Got you. Yeah, so if you're looking for a more relatable, like one-for-one swap, I think the classic, like for I loop would be the right approach, right? Which is also iteration by index, right? We do the for let IDX, we set that equal to 0. We do the whole while index is less than my array dot length, right? So there's a little bit of similarities there. So my array dot length range is going to return the length, or excuse me, there we're doing the length, and we're grabbing all of the values up to my array dot length. All right, and then the incrementation where we do IDX plus plus. And this again, if we console.log IDX, it would return to us the indexes.
Okay, and so my
the,
question is, these are the exact same. Like it doesn't matter. We could use one or the other.
It does not matter whether you do one or the other.
Got it.
Yeah, this one just gives you more control over how your iteration works, right? Like the for I loop gives you more control as to, hey, do you want to start from 0? Maybe you don't, right? Maybe you want to start from 2. And maybe you don't want the entire length of the array. Maybe you want to switch that up, right? Also, how often do you want to increment? Do you want to just increment by 1 or do you want to increment by 2? You could also do plus equals 2.
Whereas the other is you're going to get everything because you're going to go through the whole array.
Exactly.
Okay, that was really helpful. I would spend a lot of time getting hung up on which one should I use here between these two and wasting time. Thank you.
Yeah, of course. Yeah, it's a matter of control in that one. All right. Awesome. I'll break down that for I loop one more time here shortly. So it doesn't seem like we have any questions over iterating by index. So now we're going to go ahead and start talking about how to iterate by value. So I believe somebody mentioned it, which I believe it was Keith, right? Iteration by index or value in JavaScript is not very complicated. All we're doing is we're simply just switching the in keyword or of. And now our variable should be descriptive to what we're holding. We're no longer going to be iterating through the index, so IDX doesn't necessarily fit very well. Instead, I like to utilize something like ele for element. Num is a good one for numbers, or char is a good one for representing a single character. All right, in this case, num makes the most sense. I can go ahead and console.log num, and that will grab each element. And same thing for Python. I could say for num in. Notice that the in keyword never changed, but in this case, because I'm going through the elements, I would just specify my list. And I could print num. Now when this runs, I should get back only the elements. All right, so I see there that I get 11, 12, 13, 14, 15, 11, 12, 13, 14, 15. All right, all I did was switch the keyword in JavaScript from in to of. And in Python, I took off the range function and only utilized the actual data structure that I would want to iterate through. Any questions over iteration by value? Let's hear, Simon.
Can you do the what you did last time with the console.log index, comma, the list or array, and then the brackets index, or is that not the same since you're doing it by value?
Yeah, it's a great question, right? The question here is, hey, well, down below, I noticed that we're also able to grab not only the index, but I'm able to grab the value from the list because I'm calling the list and then the location that I'm currently on. Well, if I try to do that inside of where I'm iterating by element, this is actually going to cause an error, right? We could try it out so that we could see it. We're going to call my list at index of num. And I'm pretty sure this one's going to return undefined and not an error, but let's interact with it just so we could see it. All right. So here we can see that it returns undefined. And why is that happening? Well, in this case, I'm utilizing numbers. So it's getting a little bit confused. It's saying, hey, you're trying to access my array, which is an iterable data structure at index 11. But this only holds 0, 1, 2, 3, 4. Index 11 doesn't exist. So I get back a bunch of undefineds. All right. It has no idea what I'm talking about because it's saying, dude, index 11 is not a thing, man. I don't know what you think you're working with, but that doesn't exist in here. Right. And when I try to do the same thing in Python, rather than being relaxed, Python is just straight up telling me, hey, you're out of your mind. Fix this. Right. And it's crashing it, saying, hey, this index doesn't exist and it's out of range for this list. Does that answer your question, Simon? Awesome. I see the thumbs up. Any other questions over iteration by index or iteration by value? Awesome. Now, sometimes you're going to need both. You're going to need both iteration by index and value. So how do we do that? All right. This is where something like the enumerate function or the items function really comes into play. So let's go ahead and take a look at that. I'm going to go ahead and console.log something called myArray.entries. It's not going to take in any sort of parameter. And here, I'm just going to print my list, but I'm going to do something called enumerate. And I think that should work. Hopefully it doesn't give me some weird object. If it does, we'll just simply add the list to cast it. It did give me a weird object. Let me try this out. Boom. All right. So my array.entries, what is that giving to me? Well, it's giving me an object with array and iterator, so that's not very useful for me to actually be able to look at. I may have to actually typecast that as well into an array. Hopefully it lets me. Okay, that didn't really work. It's not giving me the ability to visualize it inside of JavaScript. But in Python, it's going to show me very well what's happening, right? It's saying, oh, okay, well, you want your iterator at the same time that you want your values, right? So here's my iterator at index 0. You have a value of 11. At index 1, you have a value of 12. At index 2, you have a value of 13, and so on, all the way until the end of the array. Notice that this is essentially just a list of list, where every nested list represents an index and value pair. Nice. So let's take a look at that. All right, I'm going to go ahead and comment this out real quick. And let's write a for loop. So I'm going to say for, I'm going to say let pair of my array dot entries. And I'm just simply going to console.log the pair. I'm going to do the same thing inside of Python. I'm going to do for, and here I'm going to do a pair in enumerate, and we're going to pass in my list. And let's print out the outcome of this pair. Well, let's see it, right? This pair, at every iteration, it's actually returning both the index and the value. This is really cool, except for the fact that now I have to deconstruct it, right? If I wanted something like the index, I would have to say, all right, well, now let IDX be equal to pair at index 0. Let value be equal to pair at index 1. And then I could actually console.log IDX, comma val. I could do the same thing here. And I could do IDX, comma val. All right, so now we're starting to get somewhere. But this turns into kind of a hassle, right? I'm grabbing each independent element from that nested array just to be able to console.log it. There's got to be a shorter syntax to be able to do this. Well, I could actually use something called destructuring. I know I am going through two elements, so I could say, hey, I need the index and the value in enumerate. And you could see that in Python, that's going to print perfectly fine. All right, I'm getting both the index and value. That is occupying the index 0 and index 1. And I can do the same thing in JavaScript. But in JavaScript, there is a little bit of more syntactical sugar. I need to add some square brackets saying I need IDX and value. And when I run this, I get both index and value. All right, I do hope we have some questions regarding this destructuring process. So if anyone has any questions, now would be the time to send it. Any questions regarding iteration by index and value at the same time? Let's hear it, Don.
For the JavaScript, why do those brackets needed there for the index between index and value?
Yeah, that's because my array.entries is essentially returning an array of arrays where we're holding an index and the value. Right? So I could go ahead and replicate this. This one should be 12, and this one should be 1. Now, I am iterating through my array.entries. That's this parental array here, right? And now because I want access to IDX and val, I need to say, hey, for this list, I want you to capture this list here, and I want you to match the variable of index to index 0 and the variable of val to index 1. So that's why we need these additional square brackets there. Does that
Super
answer your question,
helpful.
though?
Yeah,
Of course. Mohammed?
Yes. Should I always use enumerate over in range for len, since it does more than just for range len the function the list. Does that make
No.
sense?
Yeah, no, it definitely makes sense. Yeah. And when it comes to the fact of when should I use something or what is it that each independent one works and when to choose one iteration method over another, it very much depends on what your mission is, right? If I have some sort of array or if my question is, hey, I'm being given a list of different strings, and in this list of strings, I just want you to return the indexes that are even. Well, then all I need is a iteration by index, right? If I'm giving a list of strings that tells me, hey, I want you to return all the indexes for the strings that hold this many vowels inside of it, then I would need something like enumerate because I need both the index and the string, right? So it just depends on what your requirements are and like what the mission statement for the algorithm is. Does that answer your question, Mohammed?
Yes. Yeah. Thank you.
Of course. All right. Any other questions regarding iteration by index, iteration by value, or iteration by both index and value? Okay, nice. Doesn't seem like we have any questions. So let's go ahead and start talking about dictionaries now. So far, we've seen how to iterate through an array. And please note that anything that we did for the array for iteration, it also works for strings. So let me quickly demonstrate that. All right, if I run this really quick. Oh, I apologize. Looks like I was stand corrected. So everything works exactly the same for Python, but in JavaScript it's definitely true through a fit. All right, so myArray.entries. Entries is a property that is unique to JavaScript arrays. It does not fall to something like a string. So a string might be a little bit more difficult to try to iterate by both index and value. All right, let's start talking about some objects, everybody. And a good thing to talk about objects here is we could talk about a user. Looks like my Copilot has come back from its slumber. Let's go ahead and do this here, and let's talk about our user as well, where our user is going to have a key of name, and it's going to have a key of email. All right, there is our user. Now I want to iterate through this. If I do an iteration, usually iterations will only happen through keys. And that's the same thing in JavaScript. Right, let's go ahead and do a for let key in user. And here we're going to go ahead and console.log the key. You're going to notice that both of them just return keys. Well, in is a little confusing in JavaScript because we just went over it inside when we were talking about arrays. In was specific to index and not elements. So why is it that this is working for returning the keys? That is because this is an object and not an array. All right, the in keyword behaves differently. If we switch this to of, I actually don't know what this will do. Let's go ahead and try it out. All right, if I switch it to of, I just get a flat out error. All right, telling me, hey, user is not an iterable data structure. That's because it's an object. If I turn it back into in, then I get my keys that are available for me. All right. So this naturally will return to me all of my keys. If I wanted to iterate through this array, or excuse me, through these dictionaries or arrays values, I would have to make sure that I'm iterating through a list that holds only values. So I will have to state something like values. Right, same thing here for my my JavaScript here. I'm gonna do value. Whoa. There you go. Switch that to value. And I'm gonna do object dot values and pass in the user. Now, this for loop on the right-hand side is going to bring out a weird output. This is actually going to bring out indexes. And we're going to see why here shortly. When we run this, as I mentioned, the output on the JavaScript side is returning 0 and 1. The output on the Python side is actually returning the values. So now here's a question for all of you. Why is it that this for loop on the right-hand side with JavaScript is returning indexes rather than the values? Check the chat here, just in case I'm missing some things. Nice. So I see Chris has pretty much answered it for us, right? We're using the in and not the of. Well, wait a minute. Why is this a solution? I just tried iterating through all the keys utilizing of, and that gave me an error. And the reason why it gave me an error is because I was iterating through an object. But now I'm saying that I could use the of keyword. So why is it that of is acceptable when I'm iterating through values, but it's not acceptable when I'm iterating through the keys? Let's hear it, Abdel.
So since when you do it that way, the object.values returns an array of the values. So you're trying to say value of array, and that works.
Nice. Because what I'm actually iterating through is an array of values, right? So that's why I need the of. And that's actually what's happening on the right-hand side, on the left-hand side of Python as well. If I print user dot values, I'm actually iterating through a list of values. Awesome. Now, what if I want both items and keys, right? I want both of them. I want my key and my index. Let's hear it, Dom.
Sorry, before we go on there, that was a little fast for me, and I feel like it was something I get hung up on a lot. So the dot values for both JavaScript and Python is casting the values into a list and an array, and that's why, excuse me, that's why the difference for the if and the in. Could you just go over that one more time a little slower? I'm sorry, it was a lot.
No, yeah, that makes sense, right? Let's see. So we're using the object.values here. Let's go ahead and console.log that. We're passing in the user. And on the left-hand side, we're just going to go ahead and do user.values. Right? When I iterate through this, or when I execute this, this is telling me line 5, the output from object.values/user is actually just an array. Right? So this brings me back to my regular rules whenever I'm iterating. Rather than thinking that I'm iterating through an object, I should understand that what I'm iterating through here is actually an array. So that's why I need to utilize the of, because I want to grab the element. If I use in, it will grab the index, right? So that's why we use of. When it comes to Python, by Python, you're always technically iterating by the element inside of whatever it is you're dictating on the right-hand side. So that's why we never change the syntax and we could just keep the in keyword. Does that answer your question, Dom?
Yeah, super helpful. Sorry, that one was I was struggling with that concept. Appreciate
No,
it.
no problem at all. Yeah, these are great questions. All right. Now, I want to go ahead and take a look at both. All right. Well, this is going to take me to another one of those nested statements. I'm going to take a look at user.entries. I think that's what it is. Let me make sure that oh, nope, that is wrong. It is not entries. I got them backwards. This is items. And here, I'm going to go ahead and take a look at user.entries. And so this is going to be object.entries for the user. And when I run these, I'm not going to care about the iteration. You'll notice that this is giving me yet again a nested list of values, kind of like how the enumerate function and the items function worked. Excuse me, the enumerate function and the entries function worked, right? They're both returning me an array with arrays where every child holds a key value pair. Nice. Well, I could go through the process of implementing this, right? I could say, hey, we're gonna have a pair through user.items. I'm gonna have a pair of object.entries, and I want to see the pair. Right, so we could see the original pair or the original array that we're iterating through is an array of arrays where each child represents a key and value pair. When I'm iterating through it, I'm printing one pair at a time. Same thing with Python. I have a list with two tuples, which each tuple represents a key and value pair. And I'm just printing out the tuple through each iteration. All right. Any questions about this so far? Let's hear it, James.
For this method, for the pair, are we able to do the index and value like we were able to do the other ones as well, or do we have to use pair in this case?
Yeah, we can. Yeah, we could definitely deconstruct, right? We could go ahead and break this up. We could say this is a key and value. All right, we could view this as key and value. Same thing with pair here. We could break it up to its key and value. And now, when we execute this, we should see the original array of arrays or list of tuples, and then get back the key and value pairs being printed out. And all we did was destructure it.
Is there a best practice here? Is it preferred to use pair or is it preferred to use the other way?
It's preferred to destructure.
Okay.
Yeah, this is the end state. The only reason why I'm demonstrating pair is because I was trying to take us through like baby steps to this outcome. The
Gotcha.
process of destructuring can be very confusing.
Thank you.
Of course. All right. Any questions over how to iterate through both key and value pairs? Let's hear it, Abdel.
It's a silly one, but can you explain why there's a space between the key and the value in the print statement? Does it get it because of the print statement?
You're saying here and
Yeah,
here?
I'm saying, and the output, it keeps the space. Why is that?
Got you. So it keeps the space because it's two different values that are being printed out. So it just puts a space in between them so that you as a user, when you see the output, you know that this is a separate value than the one that was passed in. Awesome. All right. Any other questions? All right, everybody. If there aren't any other questions, then let's dive straight into the black sheep of all algorithms. And this is going to be the good old while loop. All right. If there is a way to avoid utilizing a while loop, I strongly suggest you do so. While loops can be extremely risky because if there's not a way to kill the process, it's just going to keep running forever and ever and ever. All right. Let's quickly take a look at this example here. What I'm going to do is I'm going to create a countdown. Which I'm going to make let, I'm going to do start, and I'm going to be making this equal to 10. I am going to be doing the same exact thing for my Python code. And this countdown, what it should be doing is it's going to run while the condition, so while start is greater than or equal to 0, I want it to print the value of start. Now let's see what happens when I try to execute this. And I'm actually not going to do this in Docker because I'm scared it's going to break something. So I'm going to run this python main.py, and you could see that it continues just outputting 10 over and over and over again. And the script's still running. What's happening? Why isn't this stopping? Let's hear, Kenny.
Not only do we have no way to change the count, but we never asked it to stop after any point, so it's just going to continue because we never told it to stop anywhere.
Nice. Yeah, this is called an infinite loop. We never defined a stop scenario, right? Or actually, we did define a stop scenario, which is when start is less than 0. But start never goes down. It always stays at 10. So because it's always 10, it's just going to continue printing 10 for an infinite amount of times. If you're curious as to how I stopped that, I actually utilized Control C on my keyboard, and that stops the infinite loop. All right. Well, there's my infinite loop, right? Something that I don't necessarily want. But I do want this counter to go down. Well, all I need to do is decrement start by 1. And I can make this while loop inside of JavaScript as well. I can say while start is greater than or equal to 0. I would like you to console.log start. And then I just want start to go down 1. Now, when I run this, I'll be able to see my JavaScript code. Here's the beginning. It starts at 10. It goes all the way down to 0. Here's my Python code where it starts at 10 and goes all the way down to 0. I don't always have to go down, right? We could do it backwards. We could say, hey, I want to start at 0 and I want to count up. So I could say, hey, while my start is less than or equal to 10, or say while my start is less than or equal to 10, I could print start. What else has to change about my code in order for this to work properly? Let me pass this question off to, let's see, Patty. What else do I have to change about my code in order for this to work properly?
I'm sorry, I was actually reading it while you were asking me. All right, so we're starting. You said we're doing it backwards.
Yeah, I want my 0 to go to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay. And sorry, and ask it one more time. I was trying to read and comprehend while you're asking me the question. Sorry.
Yeah, so because I'm going from 0 through 10, if I run this right now, is it going to work properly? And if not, what do I need to change?
I I think it would try to work, but it won't actually run properly because we haven't given it like, do we want it to count like every single digit? Do we want it to count evens or odd digits? So I think we need to give it more information as to what we're trying to count.
Okay, so what do I need to change?
Um, let's start. Honestly, I don't know right now because I'm just trying to follow along, to be honest.
Absorb? Yeah, no,
Yeah,
that's not.
I'm literally just trying to suck it all in and I'm writing key terms that you're saying as we're going. So
Yeah, and that's definitely not an issue. No, that's a good answer, right? I mean, we're trying to understand here and we're trying to figure out what's going on. Let's put into practice. Let's see what it's gonna do. I'm gonna try to execute Python again with main.py. Well, that's going all the way into negative numbers. And I could see we're already at the thousands. So this is
yeah. So
working
it
pretty
needs to
well.
stop somewhere. We didn't tell it to stop. We just let it do a run-on sentence, basically.
Okay, nice. Yeah, we maybe we're going down the right
Oh, we
track,
need
right?
return.
All
Don't we
right.
need a return, like basically we need to tell it to give us our answer back. Otherwise, it's just going to keep trying to give us answers.
No, not in this case, right? In this
Okay, never mind
case,
then.
yeah, in this case, we do have our stopping condition. We told it to stop once it gets to 10, right? We
Oh,
did
wait a
that for
minute.
both of them.
It gave us negative numbers, right? Am I seeing that correctly?
Yeah, it did give us
So
negative numbers.
our parameters are still wrong. Since we said start at 0, if I recall, technically we don't start anything at 0 because um my brain just stopped in the thought. But I know if there's some reason we don't start at 0, we have to start at 1. So we need to add it like +1 at the end or something like that to make sure it'll count properly. Unless I'm way off.
Half of that was right. We do need this to be a plus equals right, 1.
There we go. Yeah.
Yeah.
I
And
like
we
kind of get it, but like I said, I was trying to process at the same time as note taking slash multiple things at the same time.
Yeah, no, that's good. All right. And now if we run this, we can go ahead and dive into our runner. And this is going to show us both in
There we
JavaScript
go.
and
Okay.
Python climbing from 0 through 10.
Sweet. Like now that I see it there, I'm like, okay, that's what I was thinking. But in the moment when you asked me, I was too busy thinking, okay, this is what he said.
Nice.
Cool.
All right. I see a hand up. Go ahead, Nice. If you're speaking, we can't hear you.
My bad. For JavaScript, if you wanted to do +2, would it be plus plus two? Like is it by default 1 when you do plus plus or minus minus?
Yeah, that's a great question. So plus plus will always be 1. If you want to increment by 2, you could do plus
Oh, okay.
equals 2.
Okay, that makes sense.
Nice. Albert?
So I have a quick question. I forgot to change my my value from start. I ran it in the Docker and it's just counting up. How would I stop that?
Control C or Control D?
Control C or Control D.
Good to go? All right, perfect. Nice. So now we got our iterations down, we understand the while loop, but I hope you all understand why the while loop is particularly dangerous, right? If you do not make sure that you take your stopping condition and how you're going to meet your stopping condition into account whenever you're writing a while loop, you are going to end up in something called an infinite loop. Right? So please make sure that you very much have a way to account for an infinite loop. Um, while loops are mainly utilized to maintain certain algorithms. If you're not writing an algorithm that completely requires a while loop, don't use it. All right, stick to something like a for loop. Ideally, if there's any other way to solve it, don't utilize the while loop. All right. Any questions regarding while loops? I'm not sure if that hand is from earlier, Albert. Is your hand? Do you have a question?
That was my bad. I forgot to click the button.
Okay, awesome. Okay, nice. It doesn't seem like we have any questions regarding the while loop. So let's do a quick exercise here. Let me go ahead and do a couple of commenting just to make sure we're good to go. I am keeping an eye on Dakota questions, but I'm not seeing anything. Let me check our Zoom chat. Okay, I'm not seeing anything in our Zoom chat either. Let's go ahead and create a nice object for our classroom. This is the Dakota classroom. All right, in the Dakota classroom, we have things like instructors, and we have things like students. For instructors, you have a lead instructor, which in this case, it is myself. All right, your lead instructor has a name, the name of Francisco. And let's say that there's an email, which is francisco@codeplatoon.org. All right. Actually, no, this is good. All right, so there's our lead instructor. There's all of their details that are available to you guys. And then we also have our instructor, which in this case, we have the name of Kevin, and we have the email of Kevin at codeplatoon.org. Now, in addition to instructors, we have students. Which students we have, let's see, I'm gonna just write a couple of names here. We have Don, we have Patty, we have Nazir, we have, whoa, hey, get out of here. All right, there you go. We have Simon. And let's just put one more in there, which will be Albert. All right, so there we go. We have our students and we have all of our instructors. This is the Dakota classroom. I simply want to create a program that will be able to print out all of my students one by one. How can I do that? All right, I'll go ahead and start calling on somebody then. Let's start off with Abdel. How do I iterate through all of the students in the Dakota classroom?
Okay, so you're gonna have to go inside Dakota and then use the key student, and then you're inside the array, and you just either loop it to print it out or just
Okay, so you're saying that we're going to loop, so we're going to do a for in, and then where there's going to be a print statement somewhere. Okay, what's missing?
oh a keyword. So it's an array. So for student, you can use the keyword student. Yeah.
Okay, so let's do for stud in students. We're going to go ahead and print out stud. All right, and there you go. We have Dom, Patty, Nazir, Simon, and Albert. So fantastic. We were able to do a quick iteration over all of the students. Nice. Now let's bring this over to JavaScript. Here we have Dakota. Now, what I want to do is I want to build a process for being able to see what kind of instructors are available for each classroom. How can I see that? Let's hear it, Abdel.
You can add a type boolean, true or false is available. I'm not sure about the question. Is it like you trying to get who's available from what you have?
Oh, gotcha. So the output should be where in one line I see lead, and in the next console.log statement I see instructor.
You just talk about iterating it through it like we did before.
Okay, nice. So we iterate through it like we did before. I'm going to do a for loop. So I'm going to do for let, and let's go ahead and go with type. And I don't know if we're going to be utilizing an in or an of, but we're going to go through Dakota and we are going to go through instructors. Okay. And then here we're going to console.log something, which I'm assuming it will be type. What's next? Do we want to see what this is? Let's see it. Let's see what we have so far. All right, let's console.log. And let's see Dakota instructors. Well, Dakota instructors is an array with two objects. I'll make it even better. Let's take off this parental array. And let's see what we have now. Let's see, we have our lead instructor, boom. Boom, boom. All right. Now when we run it, we should have an object. How do I get back just lead and instructor?
Would you use object keys?
Awesome. Yeah, so instead of doing this, let's clarify this, right? We're gonna go through object dot keys. Oh, and maybe it is object. All right, so we have object dot keys. We pass in the object. But is this an of or is it an in?
It would be of.
Nice. Why?
Because we're accessing each individual key. So we don't want to do in because it would be the iterator of the key that we're in.
Nice. So object.keys is returning an array, right? And I want those elements, not the iterator. And now I should see lead and instructor. Fantastic. So we did quite a bit of iteration there. We're seeing some real world data, and this is some scenarios that you may encounter whenever you're working with something like an API inside of web development, right? There may be specific values that you want to grab. For example, if I'm building a nav bar or I'm building some sort of card, well, the API may give me all of the titles, and I just need to list those out. Once they clicked, then all the details display, right? So a couple of scenarios where you're going to need these iterations. All right. Again, does anyone have any questions regarding iterations? This is iteration by index, iteration by value, value and index, key and value, or while loops. Let's hear it, Abdel.
I'm just confused. What was the question statement that we just solved? Because I didn't understand what we were trying to do.
Yeah, that's a great question. That's my fault. I didn't explain it very well. What we were trying to do is we were trying to capture all the different types of instructors that are available, which in this case, there are two. There's the lead instructor and then the instructor. Awesome. All right, I'm not seeing anything in Dakota questions. Let me go ahead and check our Zoom chat just in case. I was confused for a bit because, oh, okay. Like, well, we didn't assign anyone to separate class. Yeah, that's my fault. My bad. Didn't explain it very well, but we got to a working state. Fantastic. All right, everyone. I'm gonna go ahead and stop our recording here. Right. All right. Welcome back, everyone. Before we left, we finished talking about iterations. And now we're at the portion of our curriculum where we can start talking about something called a function. Now, functions are essentially a repeated set of steps. Right? We can create a function that's eventually going to run. Actually, this isn't a hard requirement, right? But it may or it may not take in something, and it may not output something. So please know that these two are optional, right? There may be an input, there may be an output, but there is definitely a repeated set of steps within a function. Now, the idea here is essentially we're trying to make sure that we're following the dry principle, which is don't repeat yourself, right? Here's an example. We have a set of students here. And for these students, I have some integers, which are the scores that are given to the students. Earlier today, we discussed the ability to be able to give a score to all these students. All right, so I could scroll down, try to find where this if statement's at with my object. Here we go. So here's my if statements. Fantastic. I found it. Let me go ahead and grab this up. And I'm gonna copy this and bring it to the bottom here. And I'm just gonna go ahead and on comment. I'm going to go ahead and demonstrate this in Python first, and then we'll go ahead and bring in JavaScript just to give us a little bit more real estate when it comes to the screen. All right. So there we can see that we have a repeated set of steps. We have a score or an ability to check a score. And here we have our ability to be able to print out something. All right. Let's go ahead and add the rest of our conditions here, which are greater than or equal to 70. This here should print out grades at 70. And then finally we have else, we should print grades at 0. All right. So this is our conditional logic for this function where, excuse me, not this function, but for this script, where this script is meant to grab a student score and assign a letter grade to them. Okay. Well, now my script has a certain number of students. Let's go ahead and print out the current number of students. All right, so for my students, I have 7 of them. And I'm getting this output of B, this print statement, and that's happening because of this score here. Well, I have 7 different students to interact with. Now, when I'm interacting with all 7 of these students, I definitely don't want to have to pass each one of them in one by one, write this logic all over again, right? Like, for example, I don't want to have to, hey, for student 1, so let's say score, which is for student 1, would be something like, hey, students at index 0, I want to get the value of score. Right? This would give me back the very first student. And I could see that that is a B. Nice. 88. That is definitely a B. Let's go ahead and change this for index 1. All right, if I run this, that's going to give me 7, which is a C. Nice. So I can see that this is working, and it's a repeated set of steps. But in order for me to be able to grab every single one of these students, I'm starting to write some repetition, some code of a repeated set of steps, right? And this could turn kind of troublesome. So rather than writing this out as an independent set of steps, I can wrap all of this into a function. And I could do this in Python with the def keyword, which stands for define. Let me make sure that I am in fact recording. I am. Nice. The def keyword stands for define, and I could define a function. Let's call this function something like assign letter grade. And this function probably needs to take in something to be able to give out some sort of value. All right. Now we know that indentation marks the body of a function. So let's go ahead and indent this here, because all of this is meant to stay within the scope of the function of assigned letter grade. Well, what's missing in order for this function to work properly? What is it that I should pass in into this function in order to decide whether I'm grabbing an A, B, C, or F for a letter grade? Let's hear it, Kaylee.
I'm not sure if it's the right terminology, but like a parameter.
Yeah, nice. A parameter, right? And I can name this parameter something like score, right? It would help it be able to fit properly. And now I have an assigned set of steps with a parameter named score, meaning that I'm looking to accept one argument, and I should be able to assign a letter grade. Okay, so far I have my function body already checked. I am requiring a parameter, and the parameter that I am requiring is of score. And what I'm going to output is a letter grade. Okay, so I just need to specify how this all works. Let's check this out. All right. Now that I have this function, I'm going to go ahead and call it. And I call a function by actually writing the name and then calling the parentheses. This parentheses is what triggers the function call. Let's take a look at what this does, right? Let's not add the parentheses. Let's print and see what kind of output we get back from our runner. So here we're getting an output telling me, hey, there is what you're printing right now is a function. The function name is assign letter grade, and it currently lives in this memory location. And it's giving me a memory location inside of my machine where it's currently saving that assigned letter grade. All right. Now, the moment I call the function, let's see what it does now. Well, when I call the function, it's telling me, hey, this can't work because we're missing a positional argument of score. Right? Here's my argument of score. Well, I made it a requirement, meaning that my function doesn't work unless I pass in a score. Okay, so let's actually do that, right? How do we actually pass in a score from this list here? I'll give you all a hint. We have to iterate at some point. Let's hear it, Kaylee.
Would it be student dot get parentheses names and then the square brackets and the particular index of the name we wanted?
Okay, got you. So we do have a lot of the pieces that we need. They're just a little bit of unorganized, right? So the first data structure that we're interacting with is students. That is of a list, meaning that I have to interact by index. So this should be something like students at index 0, right? Now this dot get, that makes sense because we're actually interacting with a dictionary at index 0. But do we want name or what's the key that we're looking for?
Score.
Awesome. So we could just switch name for score. And now when we run this, we get a B. But I'm also seeing a none type. Why? Why is that happening? Why am I getting a none type for this function? Where is this none type even coming from? This year, Keith.
There's no return statement.
Awesome. There's no return statement. My assign letter value, or excuse me, my assign letter function is never returning a value. It's just printing, right? Printing is not the same thing as returning. Okay, well, let's take that a step further then. Now that I know that there's a difference between print and return, maybe I just want to replace those, right? Let's go ahead and do that. Let's grab all of these print statements, and rather than having print statements, we're going to turn them into return statements. And now we run it. Now we're just getting the letter B. Well, I was getting the letter B before. So why am I still getting the letter B, but now there's no none? What's happening? Let's hear it, Albert.
You're telling it with the return function, you're telling it to return that actual wow, I lost my train of thought. Shoot, I lost it. I'm so sorry.
No, you definitely had it, right? It's my return function. What I'm seeing printed here is the print statement in line 28, right? My function of assign letters is returning the letter B. So that falls into my print statement, and my print statement goes into my terminal and gives me the letter B. Nice. Awesome. Now this works for all of my letters. But is this really the only assignment there? Am I just doing assign by letters and that's the only point of the return function is just so I can print it? Well, no. By returning something, I could actually assign it to a variable. Right? We could call this student one score, or let's call it letter grade. If we print student one letter grade, that should still give us the output of B. What's happening? Can somebody walk that backwards for me? All right. Rather than reading the script from top to bottom, can we read the script from bottom to top? How does this work? Where is this B coming from? Let's hear it, Abdel.
Right. So because you're calling, so you said print student letter, which is the variable you declared, and in the
Okay.
variable declaration, you called the function and you called it to execute on the following arguments. You called it on students, and then the member array 0, and then you grabbed the key under name score.
Okay, nice. So if I'm following that correctly, here's my index. Here's index 0. And I'm grabbing the key of score, which gives me the value of 88. All right, so the value of 88 gets passed in where?
To assign letter grade.
Nice.
Mhm.
So the value of 88 falls into the function of assigned letter grade. Fantastic. It goes through our function call of assigned letter grade. And then what happens? What's the output here? This year, Simon.
Then it runs through the if else logic.
Nice. Okay, so we're still dealing with 88. It's running through the if-else logic. It is not greater than or equal to 90, so this is rejected. It is greater than 80, so it returns grades at 80. And what is that supposed to return?
That then goes up and looks at that object up there where 80 equals the B, which then it returns the B.
Awesome. So B gets returned. So now we know that this assigned letter grade returns B for 88. And where does this B get assigned to? Where is it stored? Let's hear it, Kaylee.
I believe it gets assigned to student one letter grade.
Awesome. And that's why this print statement here gives us the letter B. All right. Great job, everyone. Okay. Now this is really useful. But now I want to go ahead and add this letter grade to every single dictionary that's inside of the students list. How can I do that? I have my function, I have my list. How can I iterate through each dictionary, create a new key named letter grade, and then assign it the letter grade, which is the output of the function assign letter grade? Let's hear it, Kenny.
Uh, I wrote down a copy of what we have so I can look through all of it. I want to stay down by our print assign letter grade where it says student index 0. Right behind the 0 inside my square brackets, I'd like to put one regular colon so it can go from the first index all the way to the end, I believe.
Okay, so what you're talking about is slicing, right? And in this case, what we're trying to do is actually an action that happens to every single dictionary, right? So because this is an action that's going to happen to every dictionary, I could say for stud in students, if I print stud, that's going to give me each student dictionary. All right. Now, how do I give a new key to a dictionary? I want to give it the new key of letter grade. And for now, I just want to assign it to A.
I was talking about this. Um, elements.
We don't remember how to make a new key for a dictionary, everybody? Let's hear it, Kaylee.
I don't remember if it's for the key or the value, but I think it would be a sign, letter, grade, square bracket, parentheses, whatever you wanted to name it. Uh uh square bracket, and then the equal signs to the value, I think.
Okay, so you're saying square bracket and then equal sign to the value? Am I following that correctly?
No, a sign, letter, grade,
Mm-hmm.
square bracket, equal, um, and then the value for that key would be in the quotation marks, and inside the square bracket would be the name of the key, I think.
I think I'm getting lost in the way that it's being described, but we're getting very close, right? We definitely want to use this assign letter function. So I'm going to take this step by step. Gonna actually access the student. I'm gonna add a new key. Here, the key is going to be of letter grade. And for now, I'm gonna assign it to A. Let's go ahead and dive through this. You can see that all of our students now have a letter grade of A. But this isn't right. Right? The letter grade should be dependent on their score. So we fix that by assigning it to the value of our function of assigned letter grade, where we pass in stud.get, and here we're passing in the grade. Okay, so we're getting a little bit of an issue there. Let's see. None type an integer is greater than or equal to. Let's see, where did I get a none type? Oh, I called it grade and not score. That will do it. And now when it comes out, the letter grade gets assigned appropriately. All right, so this is just a quick example of how iteration can become really powerful. We're doing this for every single dictionary in the list. And we're also utilizing our function to conduct that repeated number of steps rather than having to write it over and over again inside of this for loop. All right. Any questions for me? Let's do a little bit of a deeper dive into the function. As of now, my function, if it doesn't receive an argument, it automatically fails. It tells me, hey, there's a missing required argument of positional score. But what if I wanted to make it optional or give it a default value? I can come to my function declaration and make it equal to none. Right? There is going to be a different error that I'm going to receive now. The error that I'm receiving now is between a none type object and an integer for score. That's when I'm asking if score is greater than or equal to. All right. In this case, I could just say, hey, if not score, or I could even make it better if score is equal to none. Oh, Jesus. Python, JavaScript. We can go ahead and return F. And now when we run it, my function won't fall into any failures, but everybody is going to get an F. How's this working? Why is everybody getting an F now? Let's hear it, Kenny.
Since you're getting none instead of an actual integer, it's more or less equating it to 0 and going everyone bomb because I don't have anyone higher than 70.
Nice. So how do I fix it so that it's actually accepting people's scores again?
Would we have to switch it over to integers or floats, which we don't have any, so integers.
All right, Simon.
You need to actually call it in the argument on assigned letter grade so that it doesn't go to the default of none in the parameter in the function name.
Nice. So our parameter score has a default value of none. This is if nothing gets passed in. But because something is going to be passed in, we could pass in stud.get score. And now it's going to work properly. All right, you can see that everybody has their appropriate letter grades now. And that is because if there's no value being passed, score will assume none. But if there is a value that gets passed or an argument that gets passed, then it's going to assume that argument's value. All right, fantastic. Does anyone have any questions regarding functions, parameters, or arguments? Easy peasy. Let's see this in JavaScript as well. All right, so this is my JavaScript code. All right, inside of JavaScript, I want to essentially create a function. And in this case, my keyword is function. That is going to be called assign letter grade. This function is going to take in a parameter of score that I'm going to give the default value of null. If in this function there is no score, so I could go ahead and state, hey, if score is equal to null, then I just simply want to return F. And otherwise, I'm going to go ahead and create a grades object. Now it's going to have 90, which is going to be set to A. Oh, there you go. We're going to have 80. That is going to be set to B. 70. That is going to be set to C. And then anything below that would be 0. And that is going to be set to F. Now I'm going to start with my if statements. I'm going to do if score is greater than or equal to 90. Then I would like to return grades at 90. And I forgot to actually add a let statement in there. Else if score is greater than or equal to 80, I would like to return grades at 80. Else if score is greater than or equal to 70, I want to return grades at 70. And then finally, my else statement, which is just going to return F. All right. Any questions over how we built this function? Okay, I'm not seeing any questions. Let's go ahead and call it now. I'm going to iterate. So I'm going to use the for let stud of students. That's iteration by value. And I'm going to say, hey, for every single stud that I interact with, I'm going to add a key called letter grade. And I'm going to assign it to the output of assign letter grade. Where I'm going to be passing in stud dot score. And then finally, let's console.log the students. All right, so when we run this, you can see we have our node output that holds all of our letter grades appropriately, and we have our Python output that also holds our letter grades appropriately. Does anyone have any questions regarding functions? Let's hear it, James.
I just had a quick question about adding the key and value.
Yeah, go
Since
for
it's
it.
in quotes, can we technically just write whatever we want? Just a random question. Like, if we didn't follow the same, what is that, camel casing? Could we like put an underscore there and every, or does it matter how we write it?
You're talking about 26, right?
Yeah, 26. So the key that we're putting in there, you put in camel casing, right? Could
Mhm.
we literally just put it in what's the one that Python uses?
Snake
If we
casing?
snake casing if we wanted to?
Yeah, we could. This is just a variable, or you could think of it as a variable. You can name it
Okay.
whatever you would like, and it would work exactly the same.
That makes sense. Okay. Thank you.
Of course. All right, before we move into shorthand functions, I need to make sure that we all understand functions. So if I could get a quick thumbs up or a classroom assessment regarding functions really quick, that would be great. All right, Chris, got you. All right, awesome. So it looks like we got functions under control. Let's start talking about some shorthand functions. Now, shorthand functions are specifically useful when dealing both with JavaScript or Python methods. There are methods inside of both Python and JavaScript that take in two parameters. Sometimes it's a function and then an argument. So let's concentrate around the function portion first, right? I want to write a shorthand function that's going to take in a number and then multiply it by 2. Well, if I were to do that regularly, I could just do def, let's call it multiply by 2. Well, I know that this multiply by 2 should take in a num, and I should simply return num times 2. Right? I could do this inside of JavaScript as well. I just need to change this for function. And there you go. There. All right, there's my function for being able to multiply by 2. And we could call it. We call it multiply by 2. We'll pass in 4. We could call multiply by 2, pass in 4. We may want to console.log this. And we may want to print this. When this gets executed by my runner, I see that the output is 8 for both Python and JavaScript. Now, this is awesome. But let's start experimenting with something called a shorthand function. In JavaScript, these are referenced to as arrow functions, right? And we could just do mult by 2. This function is going to take in a number. And we are going to return the value of that number times 2. Notice that when I execute this, I get the same exact output. Or I might, if I might have spelled this correctly. Let's see what's going on here. Da-da-da. Boom. Console.log multiply by 2 is not defined. There you go. That will do it. This is mult by 2. I've been hit by my own laziness. And there you go. I see that 8 gets outputted. This shorthand function essentially defines the parameter. Right? So this is the parameter that I'm going to be taking in. And this is my return statement. That is all I'm doing. I am defining a function, that's the function name, that takes in a parameter and returns automatically. The same thing could be done inside of Python. And you do this using a lambda function. We call lambda, we take in a number, and what we return is the number times 2. You'll see that when this gets executed, both of them are returning the value of 8. The argument is a 4. That falls into the value for the parameter of num. And our return statement is a 4 times 2 and 4 times 2. So we get 8 and 8, both in JavaScript and Python. Any questions regarding shorthand functions? Let's hear it, Don.
I'm sorry, I feel dumb here. The syntax for the shorthand is lambda, that's a keyword? Is that what we should call that?
It is, yes. This is a keyword. It's a reserved word for specifying that this is a shorthand function.
Okay. And then how did you choose the num there?
Num is a parameter, so we could name it whatever we would like, right? I could
Okay.
name it x, x, and that still would execute the same.
Got it. Thank you.
Of course. Yeah, I just chose num because it's descriptive as to what I want, right? I want there to be a number or an integer that gets passed in, so I'm putting num. All right, James, go ahead.
Piggybacking off of Dom's question, what's the keyword that we're using for JavaScript? Is it constant? Or is it the fact it's equal and then what is that, greater than?
Yeah, it's a great question. It's actually the latter. It's this
Okay.
arrow function here. That's what defines it as a key, not a keyword, but this arrow function is a key syntax, I guess, that turns this into a function.
Okay. So that's our signifier that we're going to do like a shorthand essentially.
Right.
Okay.
And
Gotcha.
again, these are called arrow functions, right? Because it generates an arrow. Any other questions? Okay, well, you may be asking yourself, what is this useful for? Why do I even have this? Well, this comes really useful when we have something like a built-in function that requires us to pass in both a parameter and a function. So currently we have nums here, and we have nums here as well. Now, what we're going to do is we're actually going to filter this down to only get back the numbers that are divisible by 2. I just want even numbers to come out of this. Okay, well, how can I do that? How can I actually make sure that all I'm receiving are even numbers? Anybody want to walk me through this? Go over it, Del.
You want to loop forward, or do you want to use the filter in Python?
Let's loop first, and then we'll do the filter.
That's good. So, for num in nums, you want to print or return? Return.
Print.
Print. Okay. So if
Here, let me help you out. Let's do ends be equal to this, and then let's do print ends.
if num modulo 2 equals 0,
Okay, so if num modulo 2 is equal to 0,
and answers dot can append, and then parentheses, yep, num.
fantastic. Awesome. So let's go ahead and execute this. And now this is going to come back with just 2 and 4. This is a very good example of a filtering, right? We are cutting down, we are filtering the values to something that it can only be met by modulo 2, right? This is an if statement, and this here evaluates to true or false. This is also a repeated behavior. So we could write a lambda function that does this. All right, we could say, hey, I want to check if something is even. This should be equal to a lambda function. It's going to take in a number, and I want to return if number modulo 2 is equal to 0. All right, we could pass this into the function. We could say, hey, this is even, and I want to pass in the number, and we can execute this. All right, that still works perfectly fine. It is giving me 2 and 4. Nice. So my lambda function is being taken into place. Well, oh, I see you have a hand up. Go ahead, Dom.
Sorry, I'm still trying to wrap my head around these shorthand functions, and
Mhm.
and tell me if this makes sense. I'm just trying to think about this framework here. like a lot of times when I'm thinking about writing the pseudocode, I'm like, okay, like the algorithm is asking me to figure out, is this even? Which numbers in this list are even. So by doing this shorthand here, you can set that answer up sooner and then just call it in the for loop again later. So it kind of mirrors how your brain might think about this a little bit more in the pseudocode. Is that am I making sense there? Is that or have I got
Yeah,
that?
you're absolutely making sense. Yeah, and you're following something called the single responsibility principle, right? Which is where a function should do one thing and do it correctly. So it's not uncommon to have a lot of helper functions and then just use them within a for loop to be able to come up with an answer. So that's what you're describing to me there, Dom.
Okay, sorry to slow it down. It's slow for me here.
No, no problem at all. This is good. Please, if anybody has questions, raise your hand up. I know this is a complex topic. All right. Now, currently what we're doing is we're building out an entire answer here. And we're going to actually continue that process, right? This answer, all I want is the evens. Well, I'm going to call the filter function. This is built in into Python. And notice that it's asking me for a couple of things. It's asking me for a function that I have to define. All right, well, the function that I need is even. And then it's asking me for an iterable data structure. Well, the iterable data structure is nums. Let's run this now. This returns a weird object. It doesn't really help me, and it doesn't really show me if it worked or it didn't. So we actually have to typecast this back into a list. And now you'll see that we simply get only 2 and 4. Right? So what's happening in there? Well, I'm passing in my iterable data structure. And I'm saying, hey, I want to filter down. And I want to filter down where for this entire iterable data structure, I get another list, but the only components in this list should be the ones that evaluate to true when put through this function. So only 2 and 4 evaluate to true. So my output is 2 and 4. If I really wanted to make this even more troublesome, I could put it all inside of one line, just like this. And that would still return to me the same output of just 2 and 4. Any questions regarding the filter function? Let's hear it, James.
I think I'm struggling on this too. But for num, how does it know that? I don't know how to word this, but it's like it's going through each of the values in the list, right? But how does num know to do that? I know we're
Yeah.
specifying num, but is it just the way that it's written? I don't really know how to ask the question, I guess.
No, this is a good question. All right, let's go ahead and bring this back this way. And let's do this by destructuring what function looks like under the hood. All right, so now I'm going to define a function named filter. This function here is going to take in two things. It's going to take in a function call, and it's going to take in an iterable data structure. All right. Now the iterable data structure is nums. And here I have a return value, which I'm going to reference to as filtered outcome. I'm going to iterate through each element in the iterable data structure. I'm then going to ask the function call to take in the element. If that evaluates to true, then I'm going to dive into my filtered outcome and I'm going to append the element. at the very end, I'm going to return my filtered outcome. So that's what the filter function is doing underneath the hood, right? Now let's call it. Let's actually create our and statement that we have here. And I'm actually going to name this my filter just so that it doesn't get confused with the filter keyword. And I'm going to call my filter. Now my filter requires two things. It requires a function and an iterable data structure. The function that I have is even. And the iterable data structure that I'm passing in is nums. When I run this, it returns to me 2 and 4. All right. So what's actually happening here in this my filter? Well, the first argument that I'm receiving is a function. My function is even. This is going to return true or false. The second structure that I'm passing in is nums, which is just an iterable data structure. All right. Then I'm saying for element in iter. Well, iter is nums. Each element is 1, 2, 3, and 4. All right, so element is representing 1, 2, 3, and 4. And then calling the function element. Well, the function here is even. And I'm passing in the element from the iterable data structure. This is going to determine false, true, false, and true. For the ones that it is true, which is 2 and 4, I'm going to append it to my filtered outcome. And then my filtered outcome gets returned, stored under ands, and I print out ands into my terminal. Did that help at all?
Yeah, I think so. Just so I understand this correctly, is the filter function kind of like a stored procedure in SQL then? It runs the entire like code, if you will, like that's all condensed into what filter does.
Yeah, it's essentially that's what built-in functions are, right? They have some code that's running underneath the hood to be able to provide an outcome.
Okay, that makes a lot more sense. Thank you.
Of course. Any other questions regarding this filtered function? All right. It doesn't seem like we have any other questions. I'm going to comment this out so that you all have it available in the notes, but it should work this way. Let me make sure that still runs. Nice. All right. So now let's try to actually activate this inside of JavaScript because JavaScript holds the same functionality. All right. In JavaScript, I should be able to console.log something called answer. I'm going to make a variable named answer. And I'm going to set this to nums.filter. This again is going to take in a arrow function where for every value inside of nums, I'm going to call a variable named num. And I want to simply check if num modulo 2 is equal to 0. When I run this to my runner, both of them will give me back 2 and 4. One of them is using a lambda function. The other is using an arrow function. All right, and I could also attest this as well. I could write this as is, or let's make a is even be equal to num, where for every num, I want to check if num modulo 2 is equal to 0. And I'm missing an equal sign. All right, and for this filter, we could just pass in is even. Any questions regarding the filter method and the filter function? All right, if we don't have any questions, then let's start talking about the map function. So the map function and the filter function work very much, not the same, but they're very similar to one another. All the map function is going to do is it's going to create a copy of the same thing as nums, but it's going to apply some sort of logic into it. So let's actually do nums2. This is going to take in a list of the map function. The map function is going to require a function first. I'm going to call lambda, which is going to be num. For every number, I'm going to multiply it times 2. And then the second argument is going to be the iterable data structure. If I print nums2 now, I should be able to see all of those values multiplied times 2. All right, it's grabbing 1 times 2, 2 times 2, 3 times 2, and 4 times 2. And the same thing could be said inside of JavaScript. In JavaScript, I can simply say nums2, make this equal to nums.map, where for every number, we're multiplying the number times 2. All right. Any questions regarding the mapping function? Notice that filtering is decreasing our value and it's looking for a truthy or falsy statement. And mapping is essentially keeping the same number of elements, it's just applying logic to each element. All right, I know this is a difficult one. Currently, it is 4:55. Let's go ahead and take a 5-minute break. We'll come back at 5 o'clock and we'll continue on with the lecture. But I just want you all to let this kind of sit, generate any questions that you may have. And then when we come back, you can go ahead and, plug away. I want to make sure that we don't leave here confused regarding these methods. All right, thank you so much, everybody. And I'll see everybody back in 5. Let's go ahead and resume our lecture here. So now that we had a little bit of time to kind of digest this and try to understand what it is that's going on, I wanted to open up for questions, right? The idea here isn't for you to have full understanding, but to at least have understanding enough to have some questions. So what's going on, everyone? All right, let's hear it, Albert.
It's not more of a question, it's more of an understanding thing when it comes to lambda and the arrow function. I understand and I can read the arrow function, but when I try and translate it to lambda, I'm just not getting it, I guess. Like there's a loss in translation type when I'm trying to like hop over to Python and figure that one out.
Gotcha. Yeah. So when it comes to the lambda portion, right? So the lambda is taken in num and num times 2. That's actually what's happening here. That's the arrow function, right? Where we're taking in a variable of num, and then multiplying num times 2, multiplying num times 2. This is where those two are interchangeable, right? We're calling nums, which is the iterable data structure in JavaScript here. In Python, we're calling it here. So that's where those two attach. And then finally, the map function. Right? So the map function is being called in Python as the parent, In JavaScript, it's called as a method. And that's where those two attach. Did that help at all, or did I just make us mess on the screen for no reason?
No, you did good. It's just, I guess it's one of those things I just got to keep working on. Like now, I understand with the arrows, like where they're all connecting. Oh, what is popping up on my screen? I'm understanding where everything is connecting. It's just one of those things where I just got to keep working at it to get it to stick.
Yeah, absolutely. All right, Kenny?
Oh, I was gonna say for Albert, I understood it better by reading it backwards, like for my lambda function of number, and then my colon is my equal greater than. So that's how I understood it. Like, okay, it's processing it. It just looks a little bit differently.
Okay, nice. Let's hear it, Edward.
I want to add on to that. I think I see that a little differently. It looks like the lambda is the arrow function, and then the semicolon is just kind of like the separator. But the the lambda just basically tells that the number is multiplied by two, and then has the it's just like replacing lambda with the arrow function. And how you read it backwards. That's kind of how I'm reading it.
Yeah, the lambda and the arrow function are the equivalent of one another here. Nice. Okay, so it doesn't seem like we have any more questions. So let's go ahead and talk about something a little bit more complicated than just these two, right? Just in case we didn't think this was complicated enough, we're going to go ahead and dive into a more complex example. Now, this has to do with students. We're going to interact with students, and what we're going to do is we're going to sort students. But we're not going to sort students by key. We're not going to sort students by their name. We're going to sort students by a specific key that we want. Now, this can become very complex if I was trying to write this out in just pure Pythonic code. But there is something called a sorted function. So let's see, we have sorted students. And for sorted students, what I'm going to do is I'm going to call a list of the function named sorted. Now the function sorted is going to take in first an iterable structure. This is of students. Next, it's going to take in a key. Now for this key, what I'm actually going to set is a lambda function. In this lambda function, I'm going to say, hey, every time you sort, I want you to grab a singular stud, and I want you to return for that singular stud, stud.get score. That is the key that you're going to utilize for sorting. All right, let's print this out to see what this does. So now we can see that all of the students are sorted. They're sorted from lowest to highest. And if I wanted it to be in reverse, I could actually add a third argument, which is reverse. And this is just true or false. Now it's from highest to smallest. If I turn this back to false, it will be from smallest to highest. All right. Any questions regarding the sorted function? Okay. No questions regarding the sorted function. Now let's talk about how to do this with JavaScript. In JavaScript, when I want to sort, am actually going to make a variable named sorted students or studs. And here I'm going to name it to students.sort. Now, how I conduct this sort, and it's giving me a hint there. It's saying, hey, if you want to sort, you can do something like A, comma B. And then in your arrow function, you can describe how is it that you want to compare A and B. Well, I want to compare A by score and B by score. Now, if I console.log sorted studs, I think this might actually return undefined. Okay, good. That worked correctly. All right, so there you go. We can see that everything is sorted by the score from 47 all the way to 100. If I wanted this backwards, I could just go ahead and switch B and A from one another. And there you could see we get 100, 95, 88, and so on. All right. Any questions regarding the sorted function? All right. We're going to go ahead and stop the lecture here, everyone. We've covered all of the material that we had for today.